Hey, you know that there's no video here, and you guys got some genuine swag on. You just wear
I know.
swag every day. Is that how it works?
No, I told you I did my hair. I took a shower. I put on a Genuen shirt, and I thought there was video.
Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Welcome to Making Data Simple. Again, we find ourselves here. Look, I'm going to switch gears today, and I'm going to do a little something different. I'm going to get into my electrical engineering roots. Like, we've been talking a lot about AI. We've been talking about, I think, marketing. And while I call it Making Data Simple, that's kind of where we started, and data is my backbone. We go all over the place. I've had my coach on. I do leadership. We do self-help. We're going to do electrical engineering today. Well, I mean, I don't know if it's electrical engineering, but in my mind, I'm going to talk to some engineering folks. So I'm here with Genuen, and I'll give a quick introduction. And as always, I'll let the guests introduce themselves. But Genuen is there to help organizations drive reliable performance through systems engineering and custom test equipment. To carry that a little bit further, Genuen delivers the critical test data you need across the entire development cycle, from project design and system implementation to test integration and validation. With me today, Todd Van Gilder. He's the Chief Technical Officer and the Chief Revenue Officer. 30 years of experience in test and automation. As CTO, he champions testing innovations such as Replica, which we're going to talk about today. It's one of their solutions that enables synchronization of test data across distributed real-time systems. As CRO, he's going to tell us how he does both jobs, by the way. But as CRO, Todd has played an integral role in the formation of key partnerships, expansion into new sales channels, and collaboration with the marketing and engineering teams. I also have Ryan Smith, who's a tech fellow. I presume that tech fellow is very similar to the fellows we have here at IBM. He has 25 years experience with designing and building test systems and product prototypes for sophisticated applications. This includes both hardware and software experience in avionics and rail industries. Welcome, gentlemen. Thank you for being here.
Yeah, thanks for having us. Appreciate it.
It's always difficult when you have three people because you kind of like talk over one another. So I'll try to do the best that I can by calling out names, that kind of thing. But look, we'll make it work. Maybe we'll have to do a little editing on this one. But Todd, why don't I have you go first? Why don't you give us a quick intro to yourself?
Yeah, so my background is software. So I spent a lot of years writing software for test equipment, in the same field that Genuen is, right? Helping our customers test their products. And I was more on the software end of that. I went, like a lot of engineers do in their career at some point in time. I didn't get to do what I love anymore if I wanted to go down the path of moving up the corporate ladder. So while I love software development in multiple languages, I don't get to do that much anymore. I went to what I say is the dark side and started selling. I got tapped on the shoulder and the head of sales was leaving, and they're like, well, we bring Todd on sales calls all the time in his engineering role. Why don't we just let him run the sales team? So, okay. So I started running the sales team, and then they needed a CTO, and I got tapped on the shoulder again. So you asked how I get to wear both hats. It's interesting because sometimes I'll come into the meeting as the CTO and then switch gears on him and say, I don't know if you know this, but the head of sales with Genuen's with you here today, and he's going to speak a little bit now. So I bop back and forth between the two roles as it suits me for the conversations that I'm having. So, and I've been doing this a while. Probably, if I go back to my time in the Air Force, I was in test equipment actually. So it's probably been 40 years. I've kind of been in the same field of work. Yeah.
Impressive. Look, I'm in a little bigger company with IBM, and we have technical sales along with what I would say client sales. We like to have this one-to-one relationship. Sounds like you do technical sales and client sales, meaning it's one person, one organization. You do both. Are you technical?
I maintain it well enough to pretend like I know what I'm talking about with people that do.
And then when you need, you just bring somebody like Ryan in.
Yeah, absolutely.
That fills any void.
Yeah, yes. I mean, kind of the way everybody on my sales team, there's 6 of us, has an engineering background. Most sales engineers were, not they didn't come out of college doing sales. It's something a path you go down at times. So we'll have the conversations with the customers to qualify them, to make sure it's a good lead, and because engineers are billable, we're a project-based team, so we got to be cognizant of their time and how we use it. But yes, when it gets to the point where they want to have a more technical conversation than we're comfortable with, we'll bring in the SME, subject matter expert in our company to help us go further with that conversation to try and get that PO from that customer and help them solve their problem.
So enter Ryan Smith. Ryan, why don't you introduce yourself?
Sure. My name's Ryan Smith. I'm a tech fellow here at Genuen. I've been with the organization for about just less than 20 years. I've been doing test and measurement for about 25, 26 years. Started my career in creating aerospace test systems. I appreciate the aerospace industry because it seems to be about the golden standard when it comes to design assurance levels. And the reason I appreciate that is I've been able to take that across all of the different industries. You mentioned rail before, but we've done everything from medical to ballistics to, you just about name it. I've probably done a project somehow tangentially related to that. So I really focus, what I really do is I focus where software meets hardware. So when we talk about test systems, a lot of times we're talking test racks, we're talking racks of equipment and things like that. And, writing that software to communicate with the hardware that then turns around and communicates with some kind of device under test. So when we talk about data, this is the data we're really focusing on. We're focusing on data that comes out of an instrument, kind of real world data. Whether it be analog signals or digital signals. So that's really where my focus has been. And so as part of the organization and being a tech fellow, it's kind of leading the technologies that we use when it comes to those test systems and when it comes to projects in general and eventually into product development. And so that's part of the product we'll talk about here in a little bit, but I really have a passion for where the real world meets the digital world.
How do you get the title of fellow? Is there some badge of honor you've got to achieve, or how does that work?
Well, that's a great question. I've been with the organization for a very long time, not quite from the founding of the organization, but I guess it's a proven track record of taking on complex projects and being successful and high levels of customer satisfaction.
Yeah, I guess I would add to that, when you're brought in to be the hero and save the day often enough, you got to give them a fancy title for it. So.
Makes sense. Look, we have an IBM, man. It's hell to get to fellow. Imagine committees and everything else like that. Game changers. What have you done? I presume yours is somewhat similar.
Not as formalized either. So,
when you work in a smaller organization, when you find that guy that everybody goes to, that everybody knows that is, I'll say, easy to work with and a problem solver, you become the go-to guy, and eventually you earn the respect of your peers and a title like Tech Fellow in our organization.
How many fellows are there in Genuen?
There are currently two.
So you're one of two. So it's a prestigious honor, one way or another.
Yeah, absolutely.
I
think it is.
Congrats.
Yeah, well earned.
A couple of things what you said, Ryan. I think test, I think aerospace. By the way, is your experience or your background aerospace engineering, or is it electrical engineering? Or
no, it's electrical engineering.
Yeah, same as me. Awesome. We're the best. I'll get a lot of feedback. I got test. I got aerospace. What the hell's going on with Boeing then?
There are processes to follow, and the processes are there to help ensure that these problems don't exist. And it's not fail-proof. Problems do exist, accidents do happen, but having that process is what we use to help guarantee or help try to mitigate anything like the incidents that may be occurring now. So some of it is very serious. There was a process problem up front. When you talk about the 737 MAX. Some of the problems we're seeing now aren't necessarily Boeing's fault. It's probably more potentially a maintenance problem. And so, when parts come off during a flight that have just been gone through a maintenance, it's not really Boeing's fault.
Give us a description of Genuen. I'm also curious. I know that you guys went through a name change not too long ago. Why Genuen?
Okay, I'll start that. I guess I'll start with why Genuen. So there were two companies that came together, Surtech and Weinman. We were looking to our ownership of Wyman. I am the Wyman background, was ready to retire, so we had to find an exit strategy for him. So we went out looking for a company that we thought would be synergetic with us, that was interested in acquiring us, and that was Surtech, and Ryan's from the Surtech side. And that was back in what, 2000? Well, it was the day that COVID was announced to the U.S. anyways.
2020, something like that.
Yeah,
Then
yeah,
2020.
like the Wyman side was a little unsure whether or not the Surtech side would go through it under those conditions, but we did. We weren't even in the same room with each other for a year after we merged together.
that's crazy, right?
Yeah, it was nuts. But we didn't think either name was appropriate for who we were as a company as we came together as two. So we got with our marketing team. You got to love marketing and some of the leadership. And, it was an unusual experience coming up with a different name because you got to do your diligence on these names. And we had one name, I can't remember what it was, but it turned out to mean broken car in Korean or something. So we didn't go with that one. But we like the idea of Genuen. We like the sort of the double entendre to it, right? Because we say we are a genuine company. We truly care about our customers. We have a lot of integrity that's in our core values, and it just felt right to us.
I know it as a test company, bridging between hardware and software, but you tell me, I mean, what's the better, more detailed description?
Yeah, I would like to say what we do at its core is we help our customers get their products to market in a safe way, and we kind of focus on the types of products where if they fail, lives are lost or people are seriously hurt. So, mission critical types of applications, and kind of what makes us unique in that space. And again, I'll go back to the merging of the two companies. A part of that starts with the code that you write for your embedded controller or your avionics or whatever. And so, a part of our company was very good at looking at requirements, helping them rewrite their requirements so that they were more testable, and then helping them write the test cases against those requirements, and then building the hardware in the loop equipment that does the software regression testing on that embedded controller. And kind of both companies did that. Then we kind of went further on the old Wyman side at Genuen, and we're good at building electromechanical type of equipment so that we can put that part in its actual simulated environment from a electromechanical fluid power perspective, and test it as a bigger multidiscipline system. And
why can't they do that themselves? Why do they need Genuen to do it?
Well, people ask me all the time. I'll put on my CRO hat here for a second. People ask us all the time, who do you lose to, right? That's a question you ask a seller. Who do you lose to? Well, we lose to internal. We lose to do it yourself. A lot of companies have internal resources to do these types of things, but they don't have the bandwidth to keep up with the demand because they're not going to staff, with all the cost of an employee enough to handle their high bandwidth needs. So they will bring us in to help them with that. Or sometimes they don't have the necessary skill sets to complete the project that's being tasked upon them. So they will come to us. And some companies just don't even have those capabilities. And that's where we help too.
Isn't it better to have a third party? Just in some of the examples we already started out with, to have a third party that is not guided by internal stresses, internal go-to-market requirements that are going to make you maybe skip some steps. Is it always good to go with third parties?
There's some truth to that for sure. I guess the other thing I would say to that is often and I did this in my career. I worked for Chrysler for a while in the test labs. And when you're doing it internally and you're going to be there to fix it all the time, and if something goes wrong, you can fix it. A lot of times we would refer to it as ready, shoot, aim, right? Let's buy some equipment, let's put it together. And then when you come to a company like us, we can't operate that way. We don't want to tell you that here's your equipment, we're going to stay there for a year in case something goes wrong. So you get a much more thorough design, a lot more thought put up front. You get electrical drawings, you get the source code control, and you end up with something that's sustainable and supportable and isn't a matter of tribal knowledge because you did it internally yourself. And that's another sales point that I bring up when I'm competing against do it yourself.
So I'll just add some stuff to that. All true. But in a lot of design processes, in the processes, there is a requirement for independence. And when we talk about independence, it's not necessarily, third party independence. It's, somebody that's not vested in the project, somebody that's outside of the project to do reviews and whatnot. But then I think it gives just kind of that extra little bit of flair that not only did I get somebody that was independent from the project, I got somebody who was independent from the company. So, when we come in and we do an evaluation or we do test or we do from a third party perspective, I think it gives a little bit extra validation to that process.
Yeah, makes sense. But Todd, if I asked you to put your CRO hat on again and you were to give your 2-minute pitch on why Genuen, what would that be? Just overall.
With my CRO hat or CTO? Which one did you say? CRO?
CRO. Well, this is the sales guy that's coming in saying,
okay.
Hey, you've got to go with Genuen. Here's why.
Because we're going to deliver the test equipment to you that you need based on what you're telling us, not necessarily what you're able to document in a single document. And a lot of companies will scope you to death. They'll come in low to win and they'll scope you. And we have a lot of integrity here. I'm not saying other companies don't, but we're going to make sure that the quote that we're giving you in a fixed cost is going to deliver to you exactly what you want, what you're intending, not necessarily right. We're going to color in between the lines and make sure we give you a price that takes care of that. We're not going to scope it. And we always deliver on time, and we're always honest with our customers. And again, we can take you from cradle to grave, right? We can start on the far left side of the V and go all the way to the right. Not a lot of companies can do that.
What is your customer profile? What's in and what's out? In other words, where you say, hey, this is our sweet spot. If you meet these criteria, you are our customer profile we're targeting. If you don't, or if you're X, Y, or Z, you're on the outside, and that's not who we're targeting.
Well, you got to have pain. I have to feel as though that you have a problem that we can help you with, right? That's another thing I would say about Genuen. If we can't help you, we're going to tell you as much, and we probably will even tell you somebody that can if we can't. But we need to know that you have pain, that it's a serious problem that you really have to fix. You're probably in the R&D lab somewhere. You're a lab manager of an R&D facility, because we like to work in the R&D world in particular, and then the typical things. I don't want to get salesy here on you, but you got to have budget and funding and all that other stuff that we all know about. But at the end of the day, you have to have a problem that we really truly believe we can help you with, and we have to believe that if you don't do it, you're going to lose sleep at night or whatever.
Is it, though, hardware meets software, or can it be software only? Is it all of the above?
It's all of the above. If you just need help with test case development, we have a lot of customers that's where we help them. We help develop test cases for them, and that's all that we do. In other words, it's like a pseudo language, and that's not my area of expertise. But if you have a requirement that says X, we have to write a test case that says do this, measure this, and then it has to fall within X. So we will write those test cases that eventually become requirements for the test equipment. So that's a part of our business, and we got a lot of skills in that area. If you're going to have to pass a functional safety audit, whether it's ISO 262 for automotive or DO 178 for aerospace, we can help make sure that you are collecting the right collateral, you have the right processes in place so that you will pass that audit. We don't do the audits, but we help prepare you for them. Some customers, that's the only place that we help them. So it depends on the customers. I mean, the ideal thing is we start on the left and we take them the whole way. But yeah, we have a group that's really into electromechanical, but we take a lot of software only applications on as well.
Ryan, what are some of the most prominent use cases you're working with?
So I guess it kind of depends on what part of the business. Todd's mentioned the product development lifecycle several times. We talk about the left side of the V as being the engineering side, the design side, the certification side. The right side of the V being the deployment, the maintenance, the production side. We talk about testing software on the left side of the V. So we're right. I used to say, Certec was founded, and the name Certec was Certification Technologies. And so we were helping customers through their certification process. So a lot of times we were deeply embedded in their teams, helping them write software to test their software. So that was kind of my little way of describing what I did for a while. So if there was a customer that had, software that needed tested, we do a lot of aerospace and even outer space. In those cases, a lot of times it is the actual software we're testing. In other cases, it's the hardware we're testing. So, they both have sets of requirements. They're different. A lot of times we treat them as a black box. So here's the requirements. Here's how you hook up to it, test our thing. So, I guess it kind of depends on what side of the V they're on. But, like Todd said, if they've got a problem and they can define it, or even if they can't fully define it, we help them define it. And then we go and we meet those challenges and we solve those problems.
In terms of client profile, though, you've mentioned avionics. So I assume that there's a lot in the airline industry. You have to tell me.
Sure.
I presume that also leads to government. You've also mentioned automotive. Can you say just a little bit more on, who we're targeting here?
Yeah, we kind of divide our company up into commercial and government. On the commercial side, and from a sales perspective, I'm talking about, because our engineerings are matrixed across whatever applications. But from a sales and a business development and a business strategy perspective, it's commercial and government. Commercial is divided into transportation / portfolio and aerospace. And so in the transportation / portfolio, transportation being automotive, rail, ag, heavy equipment. On the portfolio side, it's mainly industrial and medical. And then on the government side, we do a lot with the national laboratories to help them make sure that they're creating safe and reliable products. I think I can say this out loud. We help make sure that the nuclear stockpile doesn't go boom when we don't want it to, and does go boom when we want it to.
Thank you for that. Terrific. So we've got a lot of security clearances in Genuen.
Ryan and I both have. I get nervous when I talk about this kind of stuff as more I can say, but yes, sure. Ryan and I.
We'll leave it at that.
Yeah. Yes, we have a lot of security clearances.
Right. But is this like largely custom services, or is it IP that you apply to test systems and systems engineering, or is it both? All the above? Give me a little bit more insight there.
Ryan, I've been talking a lot.
Yeah, sure. So a lot of times we use what's commercially available. So if we're building a test system, a physical test system, we'll use what's commercially available. If it's not commercially available, we'll design it. So that kind of falls into the IP segment where we're creating IP specifically for a customer. If we notice that, this is more commercially viable for us as an organization, say, hey, it looks like you need this, but it looks like other people could also use this. This is when we start falling into products. So we have designed products in the past that we sell to, whoever wants to buy them, that we originally targeted for a specific customer, but we took it on and did the engineering work basically on our dime to be able to provide a product instead of a service. So yes, we do quite a bit of service. It's the bulk of what we do, but we also do provide products.
Yeah. When we talk about this rack and stack equipment and the electromechanical stuff, we're only going to get involved if you can't buy it. If you can't buy it from somebody, then we're interested. But if you can buy it from somebody, and I'm talking a full solution, not just a singular commodity, if you can't buy it, then we're interested.
I've come to learn about a replica solution. Is that one of the flagship tools that is unique and differentiated to Genuen? Or, I don't know, tell me about it.
Right.
So Replica is kind of a product we're still actively developing. It's an emerging technology. It is a space where we recognize that there's kind of no other solutions. And when we talk about this space, we're talking about sharing data amongst, I'll call it multiple processors across a network with a low latency, high speed, high bandwidth network, and trying to use as much COTS equipment to do that as possible. So what we recognized is specifically like if you take model and simulation. So if a customer's got a model or some kind of simulation they want to run, and they want to run it on a high horsepower PC, but they need to distribute that data to maybe to a node out somewhere that's actually connected to some hardware. How do you do that in a way that is very deterministic? It's repeatable, and it's high speed. There's not a bunch of latency, because a lot of times, we talk about hardware in the loop, or we talk about Hill, and what you really have to realize is that this is a closed loop operation. You output a stimulus, whatever you're testing responds somehow, and you record that and you feed that back into your model. Okay. Well, if that model isn't right there local to that node, it gets very hard to have that closed loop and not interfere with the functionality of that closed loop by introducing things like network latency. Does that kind of make sense?
Yeah. It does make sense so far. But let me see if I can say it back to you. It allows for efficient data distribution across a network, which would imply across different repositories. Could it be on-prem? Could it be cloud? I mean, what are you solving for when you use like the replica solution?
Right. So there's several use cases here. A lot of it is going to be on a local network with a specific network that is designed for this particular application, where you buy gear that is high performant and that handles the packets, because we're really talking that we're using what's called an RDMA technology, and we're using RDMA over just a standard Ethernet connection, and I call it standard. It's not really standard. I don't want to get totally down in the weeds, but if you create this network and you put other network traffic on there, like if you put YouTube on there and somebody's checking their email, you may lose performance. So when we talk about expanding this to maybe a cloud-wide or some kind of highly distributed across, say, internet technologies or whatnot, you are going to be subject to some latency and whatnot. But it is a technology that can go that far with some caveats.
Let me see if I could try this. Let me say it back to you then. Is this to really drive testing real time, essentially have applications that require real time execution, such that you don't want latency because it could slow the process down and you don't get an accurate test of, say, hardware or whatever, because you want it to be real time? I don't know if I butchered that, but does that make sense?
Yeah, that's accurate. So let me give you it's a little bit of it's not really a far-fetched scenario, but let's say that you wanted to do some kind of exercise with physical hardware, but you needed to do it across multiple facilities. Okay, you're going to need high-speed data transfer that's got low latency to be able to get that high fidelity simulation that, especially if you've got humans in the loop or something where they're doing, say, a military exercise simulation, and that data, you can't accept a lot of latency. Now, humans are, in the grand scheme of things, rather slow. But if you had a very high-performing model with a very high-performing piece of hardware that people were interacting with, they would like to see the network not be part of the problem or part of the simulation.
Look, here's what makes sense to me. I've been in development most of my career. Right now, I'm responsible for technical sales at IBM, but most of my career has been development. And when you run into issues, I would say a substantial portion of them are related to timing. Meaning, you can't recreate a problem. I don't know how many scenarios, and I was in support for a lot of years under development, where a customer calls in, they got an issue, and you can't recreate it. And it's timing. Something happens, a pointer gets switched here or there, you can't figure it out, and it's all real. You either got to slow it down to snail speed, or you got to speed it up to reduce that latency. So I kind of get what you're talking about. It really seems like you're on the speed up side, that you're taking the network out of the equation.
Absolutely. So I'll give you another example. Are you familiar with the concept of an iron bird?
I am
Okay.
not.
So in this case, an airframe manufacturer may put out all of the equipment, all the electronics that are needed for an entire aircraft. Okay. So, all the slats and flaps, controllers, and all of the electronic devices for the entire aircraft. Okay. And they want to do that so they can simulate and it's really not a simulation at this point, that everything's there, what the aircraft is going to do physically. Okay. But all of those controllers need some kind of hardware in the loop feedback response. And it's easy to take one piece of electronics and create a little hardware in the loop to where there's a nice little feedback mechanism there. But you're only testing that one piece of electronics, which has an impact on the entire airframe. Okay. So if you were simulating an aircraft that was actually flying, all of these small little electrical systems need to be tested simultaneously or stimulated simultaneously. And that all needs to feed back to a central model. So how do you distribute all of these signals to all of these different places in a way that is going to be high performant? Okay, so we can
Otherwise, at best, you got to test one by one or something.
Yeah, and that's not really a valid test, because what this one does over here on the left impacts the one on the right. So you have to have a model for the left, and you have to have a model for the right, and then you have to have a model for the entire airframe that takes into account left and right. So we need to be able to distribute all of this data to all these different places very rapidly. And that's kind of the thought. We actually designed this. We were engaged with a company that was developing a Hyperloop technology, and if you're familiar with that, it's maglev trains in a vacuum. Elon Musk came up with the concept and kind of open sourced that concept. And the reality is industry is going to a distributed nature. Okay, so if you build a car or something like that, or in this case, a bogie, basically a train car, those are now distributed ECUs throughout the entire vehicle. Okay, so those are talking to each other. But if we test those, and this is kind of where I'll say it's the birth of Replica, we were having a hard time testing all of these different nodes simultaneously with one central controller, because we couldn't talk to all of the things that were stimulating all of the ECUs fast enough. We came up with a homegrown solution that worked. It wasn't real scalable. It did what we needed it to do, but we recognized that, if there was a way to pass data between all of these different pieces of the infrastructure, this could be a really performant system. And like I said, we got it done, but it just wasn't scalable and it wasn't easy. And we thought, well, if we use traditional networks, we could do that. But traditional networks are not performant. They have a lot of latency in them. They're not deterministic. They're not real time. And so what can we do to improve upon this? And like I said, that was kind of the genesis of Replica.
Yeah. Well, and that Ironbird that he talked about was an application that I actually was a software guy still then, and managing and running that team that did that. And they used a technology called reflective memory to allow them to communicate with each other. In Replica, at the end of the day, is taking the RDMA technology that exists and creating a replacement for the reflective memory cards that were used in those systems that were very expensive and had bandwidth limitations, because the memory on those cards, the network could go real fast, and it was in the card's memory, but then to get it from the card's memory to the CPU's memory to the application space was a bottleneck. And it's just not keeping up. That technology is not meeting current demands. So we kind of created the reflective memory scenario by slicing out the memory on the CPU, on the computer's memory, and using RDMA to get those variables into that mapped memory space everywhere all at once is what Replica really is. It's taking RDMA and the concepts of reflective memory and putting it together with a lot of IP at the OS level and APIs for accessing it.
My first reaction when I listen to some of this is, look, you'd be limited by physics in some capacity or something. I mean, there's only so much you can do when you're dealing with the network. But your secret sauce in the area of quote unquote reflective memory that makes it unique, your simulation is essentially taking the network out of the equation.
Yeah, and it goes a little beyond that, because what actually happens, the RDMA technology, and I'm sorry if I'm getting into the weeds here, but basically what the RDMA technology does is it allows you to skip the OS, okay? So in a traditional, like a TCP stack, you're going through the OS, and the OS is presenting you the data that came across the network. In an RDMA network, the data comes in on the NIC, and then the NIC directly the network interface card directly places that data into the memory so that the CPU does not have to be involved. So not only did we gain efficiency because the NIC is highly efficient and the packets are prioritized across the network, but we've also taken the CPU and the operating system out of the equation of getting data into memory. And then the replica technology on top of that allows us to distribute it like reflective memory. So whatever we put on the network shows up in memory at different locations.
So now, if you have distributed real-time systems, you've got a means to do proper testing and differentiates Genuen.
Correct. And Todd had mentioned that there's technologies that exist, reflective memory. There's also things like EtherCAT, but they've got their limitations. They're either lower bandwidth, lower speed, higher latency, and so this is we're trying to build this product, or we have built this product that is uses more of a traditional network. Reflective memory a lot of times is a proprietary network. It's its own bus. There are special switches that are specifically designed for RDMA traffic. We can leverage those sometimes depending on the requirements of the system. We can use some traditional networks, but again, it's all about, I don't want to say making it easy because this stuff's hard, but the easier we can make it and the more ubiquitous the hardware is that's required, the faster we can come to a solution.
Do you always have to tailor these solutions? I presume you do, depending on the use cases that are brought to you.
So Replica is designed to be more of a generic solution, and that's kind of we wear that a little bit like a badge of honor. We are agnostic to whatever application is behind this. Okay, so if somebody wants to take on our technology and integrate it into their application, it doesn't have to be tailored. It's a network that is designed to automatically distribute your data based on your configuration.
And some of the players in this space, especially when we talk Hill, and there's some big players in that space, they find way to solve this problem. Not as eloquent as we have, we don't believe, but they find ways to solve that problem, but they're only solving it for their product line. And what we find in industry is one group over here is doing an engine controller and they're using DSpace, and someone in another system is using Vector, and I could go on with the different players in this space, or a National Instruments based Hill, and they need to come together in a system, because that's what's happening in industry is we've got to test these things not just as components, but we got to put them together like they're in the actual vehicle and they're talking to each other. And if they're not all vendor X, then how do you do that? And we're coming up with a solution that allows you to do that across those dissimilar platforms.
How is it monetized? Maybe this is the CRO, or they come out again. I mean, is it like all custom bid, or is it, if it is somewhat, I don't want to call it generic, but it is, Replica, by example, is able to apply, or is able to be utilized across different industries and different use cases, is, I'm sure there's a little bit of custom or whatever, but for the most part, agnostic. Is there a monetization strategy that, you pay for the product, you pay for subscription?
Well, we've got several licensing models like most software companies do. We've got the perpetual license per node. We've got the perpetual license per node that can float to different nodes. We've got the subscription model where, it's this much for a node per year. But if you want to change whatever node it can go on, if you wanted a floating node, then there's a price for that as well. So yeah, it's the IP. We have a license, we distribute it, we have a license manager and everything else, but it's paying for the license on a per node basis with the traditional models that you would expect in
Makes sense.
Well, and a lot of times, the products that we build are a conversation starter. A company comes to us and says, "Hey, we're interested in your product. We'd like to purchase your product." And that's when we say, "Oh, by the way, do you know we also do services? So if you need integration help with this, we can actually help you integrate this into your system and then offer all the other services that we offer."
And because of the APIs that we provide, really, they're just shared libraries wrapped in different languages. If you're a do-it-yourselfer, you install our package and then you use our APIs to integrate them into your software stack. We don't have to do it for you. We want to do it for you, but we don't have to.
So
Yeah.
Going back to a couple of questions that kind of wrap up this podcast. It's interesting that you are CTO and CRO.
Well, we kind of joked about it earlier in there, keeping up, constantly learning, constantly knowing what's out there and how it might apply to you is important. Being flexible and ready to pivot when you think, for example, the whole world's going to electrify all their vehicles, and then maybe that's not what we're going to do after all. I don't know, and figuring out what those technologies might be, whether it's hydrogen or hybrid or whatever, adapting, constantly learning. You need to understand the business more than an engineer probably wants to. All these fun things like ROI and EBITDA and return on investment and all that, right? You gotta create a product that you can afford to maintain, build, support, that's going to give you the return on investment.
So Ryan, on your side, I could ask you a ton of questions, but the one question I wanted to ask is, what's the coolest use case that you've solved? What's the coolest thing you've worked on? I mean, I know that there's got to be some stuff, maybe you can't talk about them because they're government, like we talked about earlier. But what's the coolest problem that you've solved?
Oh, we were talking about this with some colleagues recently, and it was like talking about, favorite projects. And they came up with one or two favorite projects that they really like doing. And man, I was looking back and so many problems solved, so many challenges that took head on and, derived a solution and came up with a really happy customer. I want to say that working on the Hyperloop project for us, that was a challenge. We had 4 full racks of little embedded controllers, all talking to different ECUs, doing different things. And, that was a really tough challenge. Lost a lot of sleep over that one, but in the end, the customer was extremely happy. We had an extremely flexible solution, and Genuen got the birth of a product out of it, or the idea for the birth of a product out of it. So that was one of my favorites. Any project that I'm successful on, I can take some personal pride in. Obviously, that whole job satisfaction, career satisfaction, personal satisfaction. I just love solving problems. I love taking on challenges and getting things done.
Let me ask this last question. What is true that you guys know is true? It can be anything. It could be your industry or otherwise. But do you know is true that no one agrees with you on? This is your chance.
I got an answer for that one. I do. Good. And especially like my wife and other people at home think I'm crazy too, but even professionals around me do. I think the Terminator is real. And I think that AI is going to take over the world, because I can't have a conversation without talking about it anymore. No,
we went through the whole. I didn't even mention AI, but keep going. Sorry.
Yeah, no, I think the speed at which AI has taken off. I mean, Moore's law. You gotta be kidding! It's way more than that. Just how fast it scares. Honestly, it scares me. It does. It scares me, and I think of the Terminator, and I'm half kidding and half serious. It's. I hope we can regulate it. I hope we can do the right things with it, because as much of a help to society as I truly believe it can be the beginning of the end too if we don't do it right.
I think that's a pretty good answer. I don't believe in the Terminator. What about you, Brian? You have one? You were going to jump in?
So when it comes to and this is going to sound a little nerdy and but when it comes to like the product design lifecycle, test is always an afterthought. And it should be a first-class citizen when it comes to the product development lifecycle, because ultimately companies spend a lot more money testing their product than they do designing their products. I know. That got a little nerdy, didn't it?
No. I kind of expected that a little bit. I feel like, anyway, that tests can be an afterthought because it's a cost. And it should be at the beginning of the cycle. You should work to optimize it, certainly, at least in my opinion. But I think there is, in a world of time to market, there is a tendency where if you're going to skimp, you're going to skip someplace on test, which is where you don't want to skimp. And I presume you guys live that every day.
Oh, we do. And, a part of it, too, that always frustrated me back when I was running teams that were doing this types of stuff is you got the hardware developer for the product for the company that you're trying to help. And then there's the software developers for that product. And they can slip on every deadline that they want to slip on. But the minute the two come together, they expect that test equipment to be there and working correctly. And then when you find a problem with the product, well, first you got to prove to them it's not your hardware equipment or it wasn't your software. I mean, we get beat up on hard when it comes to test equipment, and we're a cost to them, so they don't really want to deal with it too much.
Yeah, I presume there are times where you guys can't win, right? It's like when you find the problem, it's like you found the problem that's going to delay or, they need to fix, but you found the problem, which is good in the end game, but you're getting in the way of that time to market. Is this like a constant struggle with you guys?
It absolutely can be, for sure.
There's a graph that we have that we often show, and it's how long before you find a problem, how far into the product design lifecycle are you before you find that problem? And that is an exponential curve. If you find that problem early, you can fix it, and it's not that big of an impact. But if you find that problem late, that is an exponential curve, and it could cost you immensely to remedy that problem. So, not being an afterthought.
If the problem is found when the product's in market, the cost is so crazy. You would just think they would really embrace the people helping them test their products, because if they find it in the lab, way less costly. Cost in bringing that product in and recalls, but cost of life sometimes too.
Thank you guys for being here, explaining Genuen, explaining Replica. I think it was very informational, and I greatly appreciate your insight.
All right. Thanks for having us again. Appreciate it.
Thanks.
For you listeners, I always thank you because I sincerely appreciate you listening to the podcast. The listeners make it real and you keep me going. So thank you for the energy. Please rate us wherever you're at. And if you have any insight, any feedback, hit us on almartintalksdata@gmail.com. We'd love to hear from you. Thank you, and I'll talk to you next time.